Your .NET Web application is almost ready. It's calling your backend API, which connects to your database. But currently, anyone can use it. The app doesn't know who the user is. It doesn't know what they're allowed to do. It can't tell if the request comes from a trusted client or if incoming requests should be allowed at all. It's time to secure everything with Microsoft Entra. In this video, we will start by learning how to register your applications in Microsoft Entra, one for your API and one for your web app. Then we will secure your ASP.NET Core API and we will connect it to Entra so it only accepts requests with valid Entra access tokens. Next, we will see how to generate Entra access tokens and use them to test your secured API endpoints. Then, we will connect your web app to Entra and we will implement login and logout so users can log in with a real-world authentication flow. We will also learn how to show or hide UI elements based on whether the user is authenticated. And finally, we will call protected APIs from the web app using the permissions of the logged-in user. By the end of this video, your web app will have a login button that will take users to the sign-in screen in Microsoft Entra, and after a successful sign-in, the web app will receive secure tokens that it can use to both identify the user and to make secure calls to your ASP.NET Core API. Your API will validate the received token, and if the token is valid and the request is authorized, the API will do the work and respond as usual. Let's start by taking a quick look at the application that we'll be securing with Entra. What I have here is a small CRUD-style ASP.NET Core application that lets you manage the game catalog of a fictional game store. I have two other videos where I show exactly how to code this application from scratch, so please check the links in the description if you want to go over that first. Now, as you can see, the home page of this application right away shows you the game catalog. And if you wanted to add new games, all you have to do is just click on the new game button over here. And let's enter the details of a new game. Let's say Minecraft. It's going to be Kids and Family. Let's say it's $29.99. And release date is going to be 06/20/2018. Click Save. And as you can see, the game has been stored in the game catalog. And just as you can create games, you can also modify games by clicking on this edit button over here. So let's say that we want to modify FIFA. It's going to be FIFA 23 for Xbox One. And let's say that the price is going to be $19.99. Let's click on save. And our updates have been saved, as you can see right here. And finally, if you wanted to, you can also delete any game by clicking on the delete button over here. So let's click on delete on this one. I click on delete and the game is gone. So what we want to do across this video is to make sure that only authenticated users are able to modify this game catalog, meaning that only authenticated users should be able to create new games or edit games or delete games. It is okay for anonymous users to see the game catalog, but they should not be able to make any modifications. Now, this application is made up of two main components. We have our backend ASP.NET Core API that I have running in this VS Code instance. And then we also have our frontend Blazor static SSR application that I have running over here. Now, of course, we have to protect both sides of the application, but we're going to start on the backend on the ASP.NET Core API just because it is the most critical piece to protect, given that it is the one that gives direct access to the data that is managed by the application. Now, what is it that we need to protect in this ASP.NET Core API? Well, if we open up our endpoints folder over here and let's go into games endpoints and let's collapse this and let me just stop my terminal too so we can close it. And here's where we have defined all of the endpoints that make up our API. So here we have our get all endpoint, then we have our get by ID endpoint over here, then we have our post endpoint, our put endpoint, and our delete endpoint. So all of these endpoints that allow modifications to our game catalog like delete, put, and post are the ones that we want to protect. And to make it easy to work with the endpoints without having to use the front-end application all the time, I have prepared a Postman collection over here. We were able to talk directly to those endpoints as we enable the Entra integration. Now, for instance, if I go into our Get All Games request over here. I'm going to collapse this for a moment. And if I restart my server, okay, let's do .NET Run on the backend. I'll expand this a bit. And then we go back here. I can go ahead and click on send, and this is going to give me the full list of games, just as we saw on the front-end side. And if I go into collections and post create game, this is a request that allows us to actually create a game directly in the backend. So here I have prepared the payload for a brand new game. It's going to be our Astrobot game. And if I click on send here, this is going to send a request. It's going to be received directly by the backend. And as you can see right now, we're getting a 201 created, meaning that it was a success, and this game is now available in the backend. So how do we start the integration with Entra to make sure that anonymous requests like this one here cannot be sent anymore into the backend? Well, for that, let's go ahead and switch into the Entra portal over here. This is known as the Entra Admin Center, and you can reach it at entra.microsoft.com. And in order to access it, what you're going to need is an Azure subscription. If you don't have one already, I'll leave a link in the description to an article in my blog where I mention a few ways to get free Azure credits to get your subscription. And for this video, I prepared a brand new tenant that I called Game Store Corp, but you can follow along with any tenant that you have access to, whether it is the one that you use for work or any other tenant that you use for testing. And if you're not familiar with tenants, well, you can think of a tenant as your own dedicated identity environment in Microsoft Entra. So it is the one that is going to store all of your users, your API registrations, and all of your security policies. Now, for the next set of steps, you'll need to have at least the application developer role in Entra, which is the one that is going to allow you to register applications. And if you don't know which is your current role, you can always check that out by going into identity and then users. You can expand that. Then you want to go into all users. And here you should be able to find your account right there. That's my account. And if I click on that one, and perhaps I collapse the left side here and the left side over there, you're going to see that here is a section for assigned roles here on the right side. You can click on that, and that is going to reveal which are your current roles. In my case, I am a global administrator because I did create this tenant. So that's going to be more than enough for registering applications. But if you're not an administrator, you're going to need to ask an administrator to come here and click on Add Assignments. And here you're going to find the application developer role right here. This is the role that is going to allow you to go ahead and register applications. Okay, so let's close this and let's get back into the main pane. And the place where we want to go to register applications is going to be down here under Applications and in Add Registrations. Okay, let's collapse the left side for a moment. And here we can start our registration by clicking on New Registration. And here the first thing is to enter the name for our application. So in this case, this is going to be our backend API for the Game Store application. So we can name this one Game Store API. Now let's scroll down, and the next thing to do is to select what is going to be the supported account types. Now, as you can see, there are several options over here, but for the purposes of this video, we're going to stick with the accounts in this organizational directory only, so single tenant, because we're only going to allow into our application the users that have been registered with our tenant, not with any other tenant or with any personal accounts. And our backend API is only going to accept access tokens that have been generated by our tenant. Okay, so we keep scrolling down and we don't really need to enter anything else here, not for the backend at least. So let's go ahead and click on register down here. And our Game Store API application has been registered. Now, every API you register in Entra is going to need at least one scope. And this scope is what defines what kind of permissions are going to be needed by any client that wants to get access to this API. So to define your scope, what you can do is go into the Expose an API section on the left side, Expose an API. And here you can click on the Add a Scope button over here, Add a Scope. And in Entra, all of your scopes are going to be prefixed by this convention over here, which starts with API : / and then the ID that has been assigned to your app registration. So at this point, all you have to do is just click on Save and Continue. And that is going to make sure that every scope you create here is going to be prefixed with API and the ID of your app registration. Now for the scope name, this can be anything really, but in our case, this is going to be the scope that allows full access to our backend API for any clients that need them. So because of that, we're just going to name this one game store underscore API.all. Next, we have this section that says, well, who can consent? Admin and users or admins only? And for this one, we're going to select admins only because we don't want regular users to be asked to approve anything. For this specific application, we as the application owners are going to be pre-approving the application access to the API on their behalf. Now we still need to enter values for the display name, a description of this admin consent. So here let's enter full access to the game store API. And for the description, let's say allows the app to call the game store API on behalf of the signed in user. Great. So we don't need to enter anything else here. Let's just click on add scope at the bottom. And as you can see, and let me collapse this, our scope has been created. It's right here. And like I said, it is prefixed with the ID of your application registration and then the name of the scope. And with that, our application registration is complete for the backend. And it is time to switch to the code to start securing the API. So let's get back into VS Code over here. Let me stop my server. I'll close this. And what we want to do is to make sure that we require authorization for each of the endpoints that are not going to be anonymous anymore. So like we said, that is going to include post, put, and delete endpoints in this case. So here I am in the definition of my post endpoint. And all I have to do to require authorization is just go to the very end of the endpoint. And I'm going to say here dot require authorization. And what this method is going to do is to make sure that from here on, any request that lands into this endpoint has to present a valid access token with the correct permissions for our security policy. So the same way that we do this, let's go ahead and copy that line to go into our put endpoint. So let me go ahead and add here require authorization, and the same thing for our delete endpoint over there. We won't touch the get endpoints because we said that those ones are still going to be anonymous. Now, before this method can check if the incoming requests are authorized, we first need a way to validate and decode the access tokens that will be attached to those requests. And for that, we're going to need a NuGet package. So let's go into nuget.org briefly. And here we're going to look for this package named Microsoft.ASP.NET.Core.Authentication.jwt-Better. So let's search for that package. It's going to be the first hit over here. And in my case, I'm using .NET 8. So I'm going to be looking for a version that matches .NET 8. In my case, that's going to be version 8.0.15. So I'll click on that one. And I'm going to copy the line to install that package into my project. So I'll go back into VS Code. Okay, I'll open my terminal and I'll just paste that, hit enter. And now what we can do is go into our, let's scroll down here into our program.cs file so that we can configure what is known as our authentication scheme. This scheme is what is going to define how is that we're going to be validating those incoming access tokens. And to configure that, let's go ahead and here in line 9, let's add the following. Let's do builder.services, and then we will do .add authentication. So this line is going to add all of those base services for the authentication middleware. And then we need to register our authentication scheme by calling add jwt-better. And we'll need to pass in a few options here. So options, going to be a lambda expression there. And in these options, we're going to need to set two things. The first thing is going to be the authority, which we're going to just leave blank for a second. We're going to go back to this. And then we have the audience. Now, what is the authority here? Well, it is nothing more than the URL to the entity that can validate the incoming access tokens. And that entity, of course, is going to be our Entra tenant in this case. And to get the authority URL, what we can do is go back into the Entra portal over here. And let's expand this section here on the left side. Let's go into overview for our app registration. And what we can do is click on endpoints over here, endpoints. This is going to give us multiple endpoints related to our application registration and our tenant. But the endpoint that we want to use in this case is, if we scroll down here, we want to use the OpenID Connect metadata document. This is a standard endpoint in every OpenID Connect certified provider that is going to give us a lot of information about the identity provider. And to use it, let's go ahead and click on copy to get this into the clipboard so we can go back into Postman over here. And what I'll do is I'll just click plus over here to create a brand new GET request. Let's paste that over here. Let's click on send. And down here, we're going to see a bunch of information about our Entra tenant. But the main thing that we're after is this value called the issuer. This issuer represents the URL of the tenant that generates our access tokens. So it is exactly the value that we need for our authority. So let's copy that value. And let's take it back into VS Code so we can paste it over here. Okay, that is going to be our authority. Now the audience is the unique identifier of the application that is meant to receive these access tokens. And to get the value, what you can do is go back again into Entra. Let's close this endpoint section. And the value that you're after is this one here that says application or client ID. This is the unique identifier of your application, your backend API in Entra. So if we just copy this to clipboard and paste it here, this is going to allow our better scheme to make sure that every token that we're going to accept is actually meant for our API and not for any other API. And that is pretty much all we need to configure our Entra integration or to connect our API to Entra. But we do need to add one more service here. So let's go over here. Let's add the following. We're going to say builder.services.add authorization builder, because this is going to add the authorization middleware, which is capable of enforcing whichever authorization policy we have defined in our application. Now, in our case, the policy is going to be that the user has to be authenticated. So very simple, but we do need the combination of the authentication middleware and the authorization middleware to be able to successfully validate and check the permissions in the incoming access tokens. So now that our backend API has been secured with this configuration, let's see what happens if we try to send an anonymous request to any of our protected endpoints from Postman. So let me open my terminal here. I'll expand this for a bit. And then let's just do .NET run to start the application. And then let's go back into Postman, where I'm going to just close this tab over here. We don't need it. And we're going to try once again to send a post request without attaching any access token. Now I'm going to need a brand new game for this. So let me use this one that I have already prepared. So let me put that over here. Okay. Let me see if I can clean this. Clear response. We have nothing here. So now let's go ahead and hit on send. And as expected, this time we are getting a 401 unauthorized error, which is great because it means that our SPNet Core API is properly protected. Now, how can we tell our API that we are authorized to make this request? Well, for that, we'll need to attach an access token into the requests. And to get those access tokens, we need to register a client application on Entra. So let's get back into the Entra portal. Let's expand the left side. And let's go once again into our app registration section. Let's click on new registration once again. Grab the left side. And this time we're going to register an application that is going to represent our Postman client application. So let's name this one Postman. Once again, in the second section here, we're going to keep this selection of accounts in this organization directory only. So it's a single tenant application. And then at the bottom side here, we have to set the redirect URI. And this is going to be the location where Entra is going to redirect the user after the user has successfully signed in. Now, in the case of Postman, which is a desktop application, what we want to do is open up here where it says select a platform, and we want to select public client native mobile and desktop application. And this is a way to tell Entra that this is not a confidential application and that therefore it cannot store secrets. Now, for the actual URL that you want to use here, you want to use this value that I'm going to paste right here from my cheat sheet. The value is https://oout.pstmn.io/v1/callback. This is a well-known URL that the Postman application understands that it can use to read the access token after Entra generates it when the user completes the sign-in. And with that done, let's click on the register button. And our Postman app registration has been created. Now, it is not enough to just define Postman as an application on Entra. We also have to tell Entra that this Postman application is authorized to talk to our ASP.NET Core API. And to do that, we have to do the following. Let's go on the left side into the API permissions section. API permissions, then scroll down a little bit, and let's click where it says add a permission. Here we want to switch into APIs my organization uses, and here we're going to find the API that we registered previously. So in this case, let's click on Game Store API, and then let's scroll down a little bit because you have to not just select the API, but also select the actual scopes that you're going to authorize for your application. So in this case, we want to check this box over here, Game Store API all. Remember, that's the scope that we defined it. And we defined that in the backend API specifically because we need it here to authorize the client to talk to the API. So let's click on Add Permissions. And our API is going to now show over here, as you can see. But one more thing that we have to do here is to also click over here where it says Grant Admin Consent for Game Store Corp, so that we as the administrators provide consent on this client application talking to the backend API on behalf of all of the users, just so that the users don't have to be prompted for consent every time. So let's click on this and let's click on Yes. Okay, so the permission has been granted for all of the users in our tenant. And while we are in the Entra portal, it is a good time to actually create a test user that we are going to be using in Postman to sign in into Entra and get our first access token. So let's expand the left side over here and let's go back into the users and all users section. Let's click on new user. And here you're going to have different options for user creation depending on what kind of tenant you have available. In my case, I have an Entra external ID tenant, which allows me to create external users, meaning users that do not belong to my organization. That's the kind of user that makes sense for my application. So I'll click on Create New External User. Collapse this. And here I'll enter the email of my user, which is going to be his sign-in method. So I'll just enter here bob@example.com. This is a random email. So it's all fictional, but it is going to work just fine for our testing purposes. Now for display name, I'll just call this person Bob. I'll enter a password. And there are many other options that we can enter here, but we're going to go ahead and just click on Review plus Create. And then I'll click on Create. And if I click on the refresh button here, we're going to see that our brand new user, Bob, has been created. Great. Now let's go back into Postman to see how to configure it to be able to talk to our Microsoft Entra tenant. So let's go back over here. And there are a few ways to get access tokens to use with our requests in Postman, but by far the easiest way is by using this authorization tab over here, which you're going to find in all of your requests. So let's click on authorization. I'm going to collapse this. And let's start by switching the auth type to OAuth 2.0. Now, I won't get into the details of OAuth 2.0, but what you should know is that this is an industry standard protocol for letting applications securely access APIs on behalf of users. Now on the right side, we're going to set a bunch of options that are going to tell Postman how to request access tokens from Entra. So let's scroll down a little bit into the configure new token section. The first thing that we have to do is select the correct grant type. And the type we want to use is this one called authorization code with Pixie. Notice that there are a few other options available, but this option here is ideal for a public client like Postman because this is a client that cannot safely store a secret. So it is not safe to put a client secret over here because of the type of application that is Postman. And the idea of using this Pixie protection is that this is going to add a one-time code challenge that is going to protect against token interception. So next we need to enter the callback URL. And this is something that we already configured on Entra. So if we go back briefly into the Entra portal, let's expand this. Let's go back into our registrations, all applications, and let's select our Postman client over here. Let's collapse this. And if we go back into Authentication, we are going to find our callback URL, as you can see over here. So let's copy this, copy, and let's get back into Postman where we're going to put that over here. Again, this is a way to tell Entra that it needs to send back the user to this location where Postman is going to be able to extract the access token to use it with our request. Now, if we keep scrolling down, we're going to find a couple of important URLs. The first one is going to be the auth URL, which is a URL that we need to send Postman into so that the sign-in flow can start. Now, how to get that auth URL? Well, we go back into Entra. Once again, let's go into our overview in any of your app registrations. You can click again on the endpoints link over there. And the auth URL is going to be this one here that says OAuth 2.0 authorization endpoint v2. This is your auth URL. So let's copy that to clipboard and let's paste that over here. Then we need to set our access token URL, which if we go back again into the Entra portal, is going to be this URL over here. So let's go ahead and copy that URL and paste it over here. Next, we need to enter our client ID. That client ID, very easy to find. If you go back again into Entra, let's just collapse this. The client ID is the value that we have right here, application or client ID for Postman. So let's copy that, paste it over here. And like I said, we cannot set a client secret, so we're going to leave this empty. And it is not required because of the authentication flow that we're using right now, and because this is a, like I said, public client that cannot safely store secrets. So let's leave that empty. Keep going down. The next important thing to set here is going to be the scope. And where to get that scope? Well, if we go back again, Entra portal, this time we have to go back into our app registrations. So app registrations, let's go into all applications. And this time let's select Game Store API. And let's go into expose an API. And the scope that we want to use, if we lapse this, is this one over here, right? It is this scope. So let's just copy the scope. Let's get back into Postman and paste it over here. And the last thing to configure here is the client authentication over here, which you want to switch into send client credentials in body. And with that, we are ready to request our brand new access token from Entra. So let's click on the Get New Access Token button over here. And this is going to open a screen like this, which is the default sign-in dialog in Entra for your tenant. So here I'm going to be using the user that I just created. So this is going to be bob@example.com. Next, I'll enter my password, sign in, authentication is complete. I'll click on proceed. And right away, we're going to get our brand new access token that you can see right here. And as you can see, the token that Entra gave us is really just a big, long string that is not possible to understand. And that is because the token itself is encoded. So before using the token to talk to the API, one thing that I like to do is just to take a quick look at what's going on with that token to understand a little bit better the information that will be used to authorize a request. Now, to decode the token, what you can do is just copy the full text of the token. So I'll copy that. And let's get back into the browser. There are a few pages where you can do this token decoding. The one that I like to use is jwt.ms. And here in the top box, you can go ahead and paste a token. And on the bottom, you're going to see the decoded version of the token. Now, I won't spend too much time on this page, but what I want you to know is that what you see here are the different claims that somehow describe whoever requested this access token and also some information about the token itself. So for instance, this auth claim, this is the audience, and this is going to match exactly the audience that we configured in the backend API, and it's also the client ID of your Game Store API. So this audience is going to match exactly what you can see in the backend over here. If we collapse this for a moment, notice that it is that value over here. This is our audience. And if we go over here where it says issuer, ISS, this claim represents our tenant. And again, it is going to match exactly the authority that we have configured over here. So only if the token contains those exact claims, our backend API is going to be able to validate it and use it for the purposes of authorizing the request. There are many other claims over here. For instance, we can see also the name of our user here and preferred name. Here's the email and a few other things. But always when you get an access token, take the time to explore it a little bit to see what information you're going to be getting in the backend API, which is going to help you a lot with troubleshooting. Now let's go back into Postman and let's click on Use Token. When you do that, what you're going to see is that all the way to the top, the token is going to be added over here. And that means that it will be used as the authorization header when we send the request to the backend API. So now let's try out our request once again. So let's expand this a little bit. Let me clean our response and then let's click on the send button. And sure enough, we now got a 201 created, meaning that the request was a success. It was accepted by the backend API because we are presenting a valid access token. And now that we have verified that our API is able to accept Entra access tokens, it is time to switch our attention to the Blazor web app. And we can start by going back to our web browser over here and see how our application is going to react to the fact that the API endpoints are now protected. So for instance, let's say I want to change the price on the first game here. So I'll just click on edit. I'll try just changing the price to $69.97. I'll click on save. And sure enough, now we're getting an error, right? And this is an authorization error 401 because our put endpoint now requires authorization. So just like we did with Postman, now we have to configure our Blazor frontend as an application in Entra and give it proper permissions to talk to our API. So let's go back to our Entra portal over here. Let's open the left section. Let's go into applications, app registrations. And once again, let's click on new registration. Collapse this. And since this is going to be the front end for our game store, let's name this one Game Store Frontend. Then for our supported account types, once again, we're going to stick to single tenant because we're only going to allow users that have been registered with our tenant. And then let's keep going down. Of course, we now need to set up our redirect URI. Remember that this is the URI where the user is going to be redirected after a successful sign-in. But in this case, the platform that we want to choose is not going to be a public client, but this time it's going to be a web client. What does that mean? Well, that means that this is actually a confidential application, meaning that it can actually store a secret wherever that application is running because it is running on the server side. That means that Entra is going to demand that we present a client secret whenever we try to request access tokens from it. Okay. Now, for the actual redirect URL, what we can do is just go back into our browser. So of course, the user has to be redirected back into this portal. So we're going to just copy the host and port of our application, localhost 5002 in this case, okay, HTTP localhost 5002. And then we need to append the specific path where we expect the user to be redirected. Now that path is going to be sign-in OIDC, which is the default path that the OpenID Connect middleware of ASP.NET Core is going to be using. You can use a different path if you want to, but then you will have to actually stand up that endpoint in your Blazor application. Great, so let's go ahead and click on register. And our new application is ready. Now, just like we did with the Postman application, we need to authorize this application to talk to our API. So for that, let's go once again into the API permissions section on the left side. Collapse this for a moment. Scroll down. Let's click on Add Permission. Let's go into APIs my organization uses. Let's find our Game Store API. Let's click on that. Scroll down. And once again, let's check the box so that we request permissions to the scope that we defined in the API. Let's click on Add Permissions. And once again, just like we did before, we have to click on this section here that says Grant Admin Consent for Game Store Corp, so that we as the administrators are going to grant permissions to this client application to talk to the backend API on behalf of all of our users, just so that our users are not going to be prompted for permissions because we own the entire application. So let's click on Yes, and the permissions have been granted. So that is all the configuration that we need on the Entra side. And now it is time to go into the code base to start connecting the application to Entra. So let's go back into VS Code. And this is going to be our front-end code base. I'm going to stop my server, close this. And the first thing that we're going to need is a brand new NuGet package. So let's go back into our NuGet page over here. And in the search box, let's look for Microsoft.ASP.NET Core.Authentication.OpenID Connect. So let's click on search. It's going to be the first hit over here. And this is the package that knows exactly how to request and receive access tokens from any OpenID provider like Microsoft Entra. So let's go ahead and look for the right version for a .NET 8 application as I have right now. In this case, it's going to be version 8.0.15. I click on that one. I'll copy the .NET CLI command here. Then back to VS Code. I'll open up my terminal. Perhaps expand this a bit. Collapse that. Paste what I copied. Enter. And that package is going to give us the ability to start configuring the application to talk to Entra. So to do that, let's close this and let's go into our program.cs file. And just like we did with the API, we will do this configuration through a new authentication scheme. So let's scroll down here just before the line where we construct our app object. And let's start by adding the authentication middleware. So we'll do builder.services.add.authentication. Perhaps I'll send this to the next line so we can read better. And then we're going to define what is going to be our default scheme here. And in this case, we're going to say OpenID connect defaults.authentication scheme. You don't have to use this value here, which actually just says OpenID connect. You can use any value, but it has to match the name of the authentication scheme that we're going to be configuring just after this. So now in the next line, we're going to do .add OpenID connect. And here's where we're going to be giving the name to this out scheme, right? So like we said, we want to use this one as a default. So we're going to paste that over here. And now we need to set up the options for this scheme. So we'll do options. Let's open our function, go to the next line. And here's where we set a series of values that are going to define how we're going to be talking to Entra. And the first value is going to be options.authority, which is going to be, as we said before, the entity or the tenant that can validate our tokens. Now, this authority is going to be exactly the same thing as in our API. So let's go back to the API briefly so we can copy that value very quickly. So it's right here. Remember, we have it in program.cs where we configure our JWT better scheme. So I'll just copy this long value here that ends in v20. Copy that value. And I'll paste that over here. Great. The next setting here is going to be options.clientID. So this is going to be the unique identifier of our Blazor application in Entra. Where is that unique identifier? Well, easy to find. If we go back to the Entra portal and we expand a little bit this, notice that we are here in the front-end application. So go into overview and the value that you want is the one that's right here, application client ID. So let's copy that value, go back here, and let's place the value right there. The next thing that we need to specify here is the scope that we're going to be requesting from Entra. So options.scope.add, okay, and Over here, of course, we need to enter that scope that we defined for our API. Where do we find that? Well, if we go back to the Entra portal once again, let's go into app registrations. This time, let's go into all applications, go into Game Store API, expose an API, and the scope is going to be right here. So let's copy that and paste it here. Great. So those are going to be the 3 values that we need to pull from the Entra configuration. Now, the next set of values are going to define how exactly we want to perform the authentication with our Entra tenant. And the first one is going to be options.response type. And here we want to use OpenID connect response type .code. And by setting code here, what we're saying is that we want to use the authorization code flow, which is the ideal flow to use for a confidential server-side application like our Blazor web app. And it really means that when we talk to Entra, we're going to be requesting an authorization code that later we're going to be exchanging for an access token. Next, we're going to define our sign-in scheme. So it's going to be options.sign-in scheme. And this is going to be cookie authentication defaults.authentication scheme. And we want to do this because we want to tell ASP.NET Core that after the login, that login result should be stored in a cookie so that our users remains signed in across page navigations. And lastly, we want to also define here options.saveTokens equals true. And we want to do this so that the tokens that we are going to receive from Entra can be stored in the authentication ticket so that later we can access them when we want to attach them to the outgoing requests that are going to go into our ASP.NET Core API. Now, since we're saying that our sign-in scheme here is going to be the cookie scheme, what we want to do also is to make sure that we add that scheme to our set of available schemes. So just under add OpenID connect, we're going to chain a call to add cookie. And the name for this scheme must be, of course, the one that we configured before for sign-in scheme. So I'll just copy this one here, cookie authentication defaults, authentication scheme. Let's copy that and let's use it for the name of our cookie scheme. That will make sure that cookie authentication is enabled for our site. That is pretty much what we need to do to configure our authentication schemes. And now we also have to configure the authorization middleware. So for that, let's go into the next line where we're going to do builder.services.add authorization builder. Okay, so that adds all of the authorization middleware services. And for a Blazor application, the next thing that we need to add here is the cascading authentication state. So we have to do here builder.services.add cascading authentication state. And the purpose of this line is to make sure that the information of the current signing user is propagated into our Razor components so that later we can use things like the authorized view to show or hide elements based on the authentication state. And one more thing that we're going to have to add here is the following. So we have to add builder.services.addScoped, and this is going to be our authentication state provider. More specifically, on the right side, let's add server authentication state provider. And we need to add this call here so that whenever one of our Razor components requests the authentication state, it uses the server authentication state provider, which is a component that knows how to take that user info from the HTTP context and make it available to the Razor components. Also notice that we're using addScoped here because we want to make sure that the information about the user is read for the current signing user without sharing state with any other users. So yeah, so that's pretty much the configuration that we have to enable here to enable the proper authentication and authorization for our application. But there is one more thing that we are missing, which is going to be the client secret. Because remember that here we define the client ID that corresponds to our application in Entra. But we also have to specify, since this is a confidential client, we are expected to provide our options.client secret. But where to get this client secret from? Well, for that, let's go back into our Entra portal over here. And we want to go back into our app registrations, and let's go back into our game store front end. And this time we're going to go into the certificates and secrets section. Collapse this, and this is the place where we can define this client secret. And this is very straightforward. All you have to do is click here where it says new client secret. You want to enter a description. I'll just say content here. It doesn't really matter. Notice that it has an expiration that you can change. I'll leave the default over there. And then let's click on add. And our new secret has been created right here. Now the value for our secret is this one over here. And just be aware that as soon as you leave this screen, you will not be able to see this secret anymore. So it's a one-time thing. So make sure that you click over here to copy the secret value before you leave this screen. So I'll copy that, and then I'll get back into VS Code over here, where if I wanted to, I could go ahead and set the secret right here, and that would work. But of course, it is not a good practice to be storing secrets directly in your source code. So we need to find a better way to do this. And for local development, what I like to do is to use the .NET Secret Manager, which is going to allow us to store this secret outside of the code base in a separate location in your machine, but still make it available as a simple configuration value to your application. So let me show you how to do this. Let's open up our terminal, and let's make sure that we are at the location of the root of our project. And then we need to start by initializing this secret manager. We do that by using the .NET CLI with .NET user secrets init. Okay, so that will make sure that there is an entry in the secret manager for your project. So now we can start adding secrets for our project. So I'll clean this. And in order to add the secret, what you do is say .NET user secrets set. Then you want to specify both the key and the value for your secret. Now we could use any key for our client secret here. So we could say something like client secret. But since this secret is going to map directly to a value in our authentication scheme, we can do something a little bit smarter to make it easier to read the value. We can do the following. Let's set authentication schemes, OpenID connect, and then client secret. So this format here is already recognized by ASP.NET Core. And since what we're configuring over here, as you can see, is the OpenID Connect scheme, that is going to map directly into OpenID Connect over here in the secret that's going to be set. And then the client secret that we're setting here is going to map directly to the options that we are setting over here and into this options client secret. Okay. So of course, then for the value, we want to copy our secret. So let me copy that client secret, space, and then paste the secret. I'll hit enter. And that stores the secret in the secret manager. Like I said, it's going to live outside of our code base. Now, make sure that you're using exactly the convention that I am using over here, or it is not going to work. Because like I said, this is going to map by convention into our OpenID Connect scheme and into the client secret option that is over here. Now we can confirm that the secret has been set by doing clean and then .NET user secrets list. We're going to see that our secret is right here. Okay, so because we're doing this, what we can do now is just remove that client secret from our code. So let's get rid of it. And .NET is going to be able to populate the value from the secret manager as any normal configuration value into our out scheme. And with this, we are pretty much done with all of this infrastructure configuration to make sure that we can actually talk to Entra from our Blazor web application. So now it is time to start modifying our UI so that our user can actually start the login process with Entra. So let's start by adding a brand new component that is going to show this login button. So let's close this. Let's go back over here and let's go into our Solution Explorer. Collapse that. And then let's go into components, layout. I'm going to place this component just under layout. I right click, new file. And then I'll select Razor component, and I'll name this one login display. Okay, let's collapse this. And we're going to remove all of this. And this component needs to be a little bit smart so that it can show elements depending on the authorization state of the user. So because of that, we want to use this element called authorize view. And of course, we're going to have to import a namespace here. So I'll do control dot here to import the Microsoft.ASP.NET Core.Components.Authorization namespace over there. And this authorize view component is the one that allows us to say what to show if the user is authorized or if the user is not authorized. And we can do that by introducing here two sections. The first section is going to be authorized, and the other section is going to be not authorized. Now, before we do anything else here, a good tip here is to actually move this using statement here into our imports file, because we're going to be using these authorized statements in several places across the code base. So I'll do control dot here, and I'll select promote using directive to imports.razor. Okay, so with that, that import is going to be global across the entire application. And we're going to start with the not authorized section over here. So of course, when the user is not authorized, we want to show this login button. So let's add a button over here via an anchor. So it's going to be an anchor that is going to say login. And just so that it looks not too bad, let's add a little bit of a bootstrap class here. That's going to be btn and btn warning. Okay, just a little bit of styling. We will see later what to do when the user clicks on this login button and what to do in the authorized case. But for now, let's just add this component into our navigation bar so that we can see if it actually shows up in the not authorized case. So let's open our Explorer view here. I'm going to go back into my File Explorer and into the nav menu. So this is our navigation bar at the top of the page. And just under our title here, title span, I'm going to add a div. I'm going to add a little bit of styling here. The class is going to be the flex. And inside this div, I'm going to introduce our brand new login display component. Great. So that should be good enough for us to see the login button in the page. So I'm going to restart my application by doing .run. Great. Now I'll go back to my browser or here, and I'll go back to my homepage, and sure enough, our login button is showing up right there. Great. So now we know that the button shows, it is time to, well, make it do something. So let's go back to the code base. And what we want to do is to implement the endpoint that this button is going to take the user so that we can kick off the sign-in process. So for that, let me just stop my server. And what I'm going to do is the following. Let's do Ctrl+Shift+E. Let's go into our Solution Explorer. And what I'd like to do is to create a brand new folder just under the root of the project. I'll right-click that, new folder. And I'll introduce an authorization directory. And in this directory, I'll right-click, I'll do new file, class, and I'll name this one login, logout, endpoints. Okay, let's collapse this. I'll clean my namespaces at the top. And in this class, we're going to be defining a couple of minimal API endpoints similar to the ones in the backend API for login and for logout purposes. So let's start by defining this class as static because it is for extension methods. And let's define public static void map login and logout. We're going to be extending our endpoint route builder. Let's just call it endpoints. And then I find it handy to group both login and logout under a single path. So let's define first our group, which is going to be endpoints.mapgroup. And let's name this group authentication. And now under this group, let's define our mapget. The path for this endpoint is going to be just under /login. And then let's define the logic that we want to trigger when somebody lands in there. And really all we want to do here is to redirect the user into whichever page Entra uses to present that login screen for the user. And to do that, all we have to do is the following. Return results.challenge. And then we need to pass in a new authentication properties object. And I'll send this to the next line. Because for this object, we have to pass in just one property, which is going to be the redirect URI, which is the place where we need to be sent back after authentication. And this is just going to be our root, so we can just put a slash right there. Okay, so when the user is redirected into this authentication login path, what we're going to do is just call this challenge method, which is going to challenge the authentication scheme, the default scheme that we have configured for the application, which is our OpenID Connect scheme that is configured for Entra. So at that point, the middleware is going to figure out how to reach out to Entra, and Entra is going to show the login screen on the Entra side. Now, one more thing, we have to also make sure that this endpoint is anonymous, because of course the user is not expected to be logged in at this point, right? So let's make sure that we say allow anonymous at this point. Great. So that will be it. We'll talk about logout in a moment, but let's see if this login logic is going to work. So what we have to do now is go back into our program.cs file. Let's go back to program.cs, and we have to invoke that new method that we defined over there. So let's invoke app.map login and logout. And the last thing to do is to make sure that our button is actually pointing to our new endpoint, right? So let's get back into login display, and let's define our href for this anchor, which is going to be authentication/login, our brand new endpoint. Great. So with that in place, we should be ready to test our login logic. So let's open up our terminal. Let's do .NET Run. Let's go back to the browser. I'm going to refresh the browser. And let's go ahead and click on our brand new login button, which now points to our endpoint. So let's click on that. And notice that we are immediately redirected to Entra. Notice that we are no longer in our site. We are now at the location of our Entra tenant, right? Because for a secure authentication flow, the authentication screen, the sign-in screen, has to be presented by your identity provider, not by your application, but always by the identity provider. It's the only one authorized to collect these credentials from the user. And of course, here we're going to be using our test user, which is bob@example.com. Let's click on next. Let's enter our password, click sign in. I'll say not now. I'll say no. And here we're back into our portal, which is great. And first notice that the login button is no longer there, right? It has disappeared. And that is because our Razor components in Blazor are detecting that we are now authenticated, right? So there is no need to show that login button anymore. So of course, what we want to do now is to, well, show some sort of experience over there for the case where the user is already logged in, right? Like logout button and perhaps the name of the logged in user. So for that, let's go back to VS Code. Let's stop the server. And before we touch the UI elements, let's actually go into our login logout endpoints to define this endpoint that is going to be used for logging out. So for that, let's just go over here under our map get. Let's define our group.mapPost. This has to be a post call, not a get call. The endpoint is going to be under logout. And let's define our behavior here. And all we have to do here is just say return results.signout. And what you want to do here is not just call sign out, but also make sure that the user is signed out both from Entra and also from the cookie scheme, right? Otherwise, if you just sign out from Entra, the user might remain signed in using the local cookies, and that's not going to be a great experience. So what you want to do here is say authentication schemes, and then we can do an array here where we want to put cookie authentication defaults dot authentication scheme. That's our cookie scheme. Let me see if we can do this in the next line. Then we'll do comma, and then we're going to do OpenID Connect defaults dot authentication scheme. Okay, remember these are the two schemes that we define in program CS. So here we are logging out the user from both schemes. Great. So that is the endpoint, and now we have to define the UI for this. Let me close my app menu here. Let's go back to login display. And of course, now we have to work in this authorized section over there. Now, to save a little bit of time, I already have the UI prepared for this from my cheat sheet. So let me just copy that and paste it here. Okay, let's go over this. We have a div here, the flex div, that has one span section here where we're going to be presenting the name of the user. And then we have a little form here that is ready to post when we click the login button, or actually the logout button that we're defining here as a button right here, right? Here's the logout button. So the first thing to do is to, well, how do we show the logged in username? Well, we can do that very easily by using the context object over here. Now, this context object is nothing more than the authentication state that is being passed in by this authorized view component, right? So that contains the authentication state. And from there, we can go ahead and query details about the user by going into that user and that identity and then that name. Now, we're not going to care too much about nullables in this case. So I'm just going to do this. So we're going to show whatever shows out of name. It should be the sign-in name if we have configured things properly. Great. So that's the first thing. And the next thing is to configure the action for our post button, right? We have not configured the action. So right here, before the class name, let's define that we want to set an action. And the action, it just has to point to our brand new endpoint. So that's going to be authentication / logout. All right. So that is pretty much it. That's what we need to define here to define our logout experience. So, well, let's run the application and let's see what happens. So let's do .NET Run. Let's go to our browser and we are still logged in, right? So let's just refresh this. And sure enough, we have our logout button over there, which is great. But somehow we're not seeing the sign-in username there. Why is that? Well, that is a classic problem that relates to the fact that ASP.NET Core maps some of the incoming claims into the ASP.NET Core infrastructure. Now, this happens for legacy reasons, but it's very easy to fix if we modify a little bit the way that we configure our OpenID Connect middleware. So let's go ahead and stop our server. And let's get back into Program CS all the way up. Remember, this is the section where we configure the OpenID Connect middleware. And really, all we have to do here is to tell ASP.NET Core that we want to use something different for our name claim. So we want to say options.token validation parameters.name claim type equals JWT registered claim names dot name. Okay, so without doing this line here, what you're going to notice if you debug this application is that name claim type actually has a very strange and long name that, like I said, for legacy reasons is mapped into that. But we're saying here that we don't need that. We want to use a simple name claim for this. And that would allow ASP.NET Core to perfectly map the incoming claim into context user identity name over here. So let's test that. Let's go ahead and restart the application. Let's go back to the browser. And for this, we're actually going to have to log out because otherwise we're not going to be able to see that name. So let's click on our brand new logout button. Let's see if that logout process works. Let's click there. Notice we're going back into Entra to kick off the logout flow. We're going to say that we want to log out Bob in this case. And we are redirected back into our browser, which is great. So now let's log in once again. Select Bob, and then my password, not now. And sure enough, this time we can see the name of our user right there. So now that our login and logout experience is working properly, it is time to lock down our UI so that our users cannot use any of these buttons like new game or edit or delete unless the user is signing into the application. And we can do that very easily by using, once again, the authorized view component. So let's get back to VS Code and I'll stop my server now. Let's go this time into our home page, which should be under pages, home.razor. And let's define which are the elements that need to show only when the user is authorized. So for that, for instance, right here at the top, here is our new game button. So all we have to do to make sure that it only shows when the user is authenticated is to add an authorized view element here. We're just going to wrap that button. And that's pretty much all you have to do. You could define an authorized and non-authorized sections here, but by default, by just doing this, it means that it has to show when the user is authorized. Next, we want to do something similar for the buttons on the list, right? So let's go down here, and we're going to start by adding an authorized view and the header section of that table. So we're going to do authorized view. So we wrap the headers, and then let's scroll down so that we can introduce another authorized view at the TD that shows those buttons, right? So we will close that here, save, and now we have wrapped all those elements. So with that, we can restart the application, go back to the browser, and then of course the user is signed in right now, so there will be no changes. So let's actually log out to see what happens. So let's click on logout, Bob. And now that we are back, notice that all of those elements have disappeared. There is no new button there, and the entire section with the buttons to edit or delete is gone, right? Which is great. But there's one more thing that we have to take care of in terms of the UI here, and it's the fact that our users could still go directly to the edit page of a game via the address bar, right? So if I go to the address bar and I just type here edit game 1, now I am in the page to edit the game, which should not be allowed. So how can we prevent this from happening? Let's go back into our code, stop this. Let's look for that edit game page or components, this one over here. And really all we have to do here is to define that this page or this component requires authorization. And to do that, all we do is define an attribute here. So attribute, and this is going to be authorize. And to include this attribute, we need to import a namespace. So let's do control dot. We need to import Microsoft.ASP.NET Core.authorization there. And that will make sure that nobody can use this component unless a person is authorized. So let's see if that actually works. Let's go into our terminal, start application. Let's go back to the browser. And let's start by going back to my home page over here. And now I'll try to go back into that edit game 1 page. And notice that this time I am redirected into Entra because I cannot get into that page unless I have authenticated. So only after I will select Bob here and I'll go enter my password, sign in. I'll say no. And now I am able to access this location. Okay, so make sure that you take care of this, or otherwise users could still arrive to locations where you have not protected the component with the authorized attribute. And this is looking great, but of course we still have a big problem here, and is the fact that our UI, our Outplacer application, cannot yet talk to the protected endpoints. Because if we try to click save here, we are still getting our unauthorized error here. So we need to find a way to attach the correct access tokens to the outgoing request anytime we need to talk to the backend. Let's see how to do that. So let's go back into our VS Code instance, and let's start by understanding where that error is coming from. So I'm going to just close now all of my tabs here, go back to Explorer View, and the place that we want to take a look at is our clients, our games client in this case. So this is a typed HTTP client that is in charge of making all of the outgoing requests that relate to game management. So here you can see that here is the place where we make GET requests to retrieve all of the games. And then over here is the one where we post a brand new game via the HTTP client. And if we keep going down, we're going to find that this is the one that is failing right now, right? The update makes a put request, and it's going to ensure that the status code is successful. But right now it is a 401 because we don't have authorization. So what we need to do is to make sure that when we make this put request over here, we include the authorization header that has a corresponding access token in a similar way to what we did in Postman before. Now we could do this for each of our HTTP requests over here one by one, but a much better way is to use what is known as a delegating handler, which is going to be a class that is going to be in charge of automatically attach the access token for every outgoing request without having to do this one by one for each request. Let's see how to work on that. So let's go back into our Solution Explorer over here, and I'm going to actually close that. And in our authorization folder, let's just right click, let's do new file, class, And let's name this one authorization handler. Okay, let's collapse that and let's clean our spaces. And like I said, this is going to be a delegating handler. So we have to implement the delegating handler class over there. And what we need to do here is to implement one method that is called sendAsync. So we're going to override sendAsync. So protected override, sendAsync. I'm going to put the parameters here so we can see better. So it's going to receive a request and also a cancellation token. And here we need to perform two steps. The first step is to extract the access token from the HTTP context. I'm going to put that over here. So extract access token from HTTP context. And the second step is going to be to attach that token as a header to the outgoing request. So attach token to outgoing request. Okay, so let's work on the first step. So to be able to extract the token from the HTTP context, we first need access to that HTTP context. And that is something that we can get from the HTTP context accessor, which is a service that's available in ASP.NET Core and that we can easily inject here. So I'm going to add a primary constructor here where we're going to introduce HTTP context accessor. Let's name it HTTP context accessor. Send this to the next line. And now that we have access to that one, which by the way, we're going to register later in program CS. Now we can come here and say var HTTP context equals HTTP context accessor dot HTTP context. And just to watch out for the case where this might be null, let's just add the following statement where we're going to say that if it is null, we're just going to throw a new invalid operation exception. And we're going to say, well, no HTTP context available. And now we can add in the next line the following. We can say var access token equals await HTTP context dot get token async. And in this method, what we have to do is just request that access token. So it's going to be access token like that. So that is going to be the first step. So that is the access token that Entra granted us after successful authentication. And now we need to work on the second step, which is where we have to attach that token to the outgoing request. Now, it might be that for some reason we didn't get an access token, right? So it may be that the user is not authenticated just yet. So the next line we should only do if we do have an access token. So let's do a little if here. So if not, string that is null or empty the access token. Then we can go ahead and attach the token to the request. So we can do this, request dot headers authorization. So authorization is the header that you use to pass in this access token along with the request. It's going to be equals to new authentication header value. And this is going to receive two parameters. I'll send this to the next line. For the first parameter, we have to pass in better because it's going to be a better token. And for the other parameter, we're going to set the access token. Great. So that is care of step 2. And then the last thing is, of course, to just send a request with this line over here, 29, which all we're missing right now is just the await keyword here to make sure that it is an asynchronous call. Great. So that is our authorization handler, right? And now that we have this, what we have to do is make sure that it is used anytime we send a request through our type HTTP client. How to do that? Well, let's go back into Ctrl+Shift+E. Let's go into our file explorer and into our program CS file. And we're going to go into the section where we declare our client. So for instance, here is where we are registering our games client for dependency injection. So what we need to do now is to chain a call over here to the method called add HTTP message handler. And then we place here the name of our authorization handler class. So authorization handler. That's all you need to do to make sure that this handler is used for any outgoing call that goes through this games client into the location specified here. But one thing to keep in mind is that the handler has to first be injected also into the service container so that it can be used. So what I like to do is before this line, let's actually add another line that's going to do two things. The first thing is that, well, remember that we want to use the HTTP context accessor over here, the handler. So we need to register that service first. And that can be done via builder.services.add HTTP context accessor. And then we're going to just chain a call to .add transient authorization handler. And we do add transient to make sure that we run the logic in the authorization handler for every new request, as opposed to trying to share it across multiple requests. Great. And notice that we could also attach this handler to our generous client, but generous client is going to talk only to our get generous endpoint, which is anonymous, so it doesn't really need the authorization handler. So with that in place, let's restart our server and let's see if we can now submit a modification to the game catalog from the frontend. So let's go back to our frontend over here. I'll click on cancel here to go back to my homepage. And I'll try once again to edit our Final Fantasy XIV game here with a price of 69.97 in this case. I'll click on save. And sure enough, this worked without any issues right there. We could also try to create a brand new game. So let's click on new game. This is going to be The Legend of Zelda. It's going to be a role-playing game. Price is going to be $39.99. Release date 03/03/2017. Let's click on save. And the game was successfully added over here. So it's all working great. And why not? Let's also verify that delete is working. So I'll click on delete. For Minecraft, I'll click on delete. And the deletion was successful. And that completes the integration of Entra for our API and for our Blazor application. Now you know how to secure both your ASP.NET Core API and your Blazor web app using Microsoft Entra. But that is just the beginning. You might want to let users sign up without manually creating their accounts. Restrict access based on roles. Add custom data to tokens for smarter access control. Keep users sign in without suddenly kicking them out. Make authentication work seamlessly in the cloud. Or be ready to support more identity providers beyond Entra. I cover all of that and a whole lot more in the .NET Cloud Developer Bootcamp, a complete step-by-step blueprint for C# developers who want to build production-ready .NET applications for the Azure cloud at scale. You can check out all the details at .NETacademy.io/bootcamp. Thanks for watching, and I'll see you in the next one.